Welcome to Grade 12 Mathematical Literacy, Chapter 1, Conversions, and this is found on page 20 of your textbook. Calculated volume to liquid volume conversions. So you are seeing that we are dealing with length type dimensions, and liquid is going to be in liters, milliliters, etc. So let's have a look at this. It says calculate the volume of this tin. Well, volume, if you remember, was the area of the face multiplied by the distance traveled. Okay, this is a circular tin, so we're going to find the area of the circle multiplied by the distance traveled, which is 22,5 centimeters. Area of a circle is pi r squared. Remember, area is always square units. Remember to use the pi r squared formula, and we're going to multiply by 22,5 centimeters. Use your pi button on your calculator, so we're going to go pi r. Remember, I always say to you, if your diameter, so this is your diameter, equals 17, your radius is going to be 8,5 centimeters. So that will be 8,5 centimeters. That must be squared and multiplied by 22,5 centimeters. Right, make sure you've got your calculator with you. So we're going to go shift pi multiplied by brackets 8.5 close bracket squared, and we're going to multiply by 22.5, and your answer is SD 5,107,051,557. Right, there we have the volume in cubic centimeters. It would equal 5,107, 7 rounded to 1 decimal place centimeters cubed. Paint is sold in liters. So now we had the volume in cubic centimeters, which is also written as centimeters cubed. But paint is sold in liters, so we have to calculate the amount of paint this tin holds. Well, remember that there is a conversion. 1 centimeter cubed equals 1 milliliter. 1,000 centimeters cubed equals 1 liter. You need to know, and I've said before, that you only need to know this one. If you know that calculation, you can convert to liters afterwards. Right, so 1 centimeter cubed, 1 centimeter cubed to 1 milliliter. We're going to use ratio. We've got centimeters cubed to milliliters. So we must have centimeters cubed to milliliters. Look what you're converting. That is cubic centimeters. So it's 5,107,7 cubic centimeters, and that is going to be X. Right, remember the next step would be to write it in fraction form. 1 over 1 equals 5,107,7 over X. We then cross multiply, so 1 multiplied by X will be X equals 1 multiplied by 5,107 will be 5,107,7. You need to go back and check your units. X we were looking for is milliliters. So I now have 5,107,7 milliliters. I've got to change that to liters. Remember King Henry? King Henry died miserable death called measles. Now we're using liters, so this is going to be milliliters, and to go from milliliters to liters, 1, 2, 3, jumps back, so we 3 noughts, 3 places, we put a 1 in front, we are going in this direction, so we know we divide. So on your calculator, you can do that, or if you know how to divide, so in other words, your comma moves 1, 2, 3 places to the left, so that will equal 5,1077 liters. Now, if we look at the paint tin, paint is normally sold in 5, 10, 20 liter containers. So this paint tin is a 5 liter paint tin. Why did we have 1,077 at the end? Well, paint doesn't fill the entire tin. There's always breathing space at the top. So that contains 5 liters. Calculated area to liquid volume conversions. Right, so for example, here we are calculating the amount of paint needed for a wall. Calculate, the first thing you're going to do is calculate the surface area of the wall. Then you determine the paint spread of the paint. You use the spread rate as a ratio to calculate the amount of paint needed. Read the question to see whether you need 1 or 2 coats of paint. That is a method. Paper 1 would ask you to do these 4 steps one by one. A paper 2 would simply say, calculate how much paint is needed to paint the wall. Right, here's the example. A painter needs to paint a wall with a surface area of 25 meters squared. So here we've been given the 25 meters squared. The spread rate is 8 meters squared per liter. That is a rate, and rates you can write as follows. 8 meters squared per liter, per means 1 to 1 liter. That is what you are given. We use ratio to find out the other quantity, and if I've got meters squared, I must have meters squared to liters. It's very important that your ratio, if I have meters squared first, I must have meters squared first on the other side of the equal sign. I have 25 square meters, 25 square meters, and I have X liters. That is what I have to find. Next step, fraction form. 8 over 1 equals 25 over X. 8 multiplied by X is 8X equals 25. We have to get 8 on its own, so we divide by 8 so that that would cancel, and we're left with X. What we do to the one side, we do to the other. So we say X equals 25 divided by 8. 25 divided by 8 equals 3,125. 3,125. What was X? X was liters, so I have 3,125 liters. The painter needs to buy the paint, so he would have to go and buy 4 liters of paint. This is a very, very little, 125 milliliters is not very much paint, but if he didn't buy 4 liters, he would have too little paint to continue the job. So you'd have to buy 4 liters. Let's look at example 2. A builder calculates the volume of the foundation. So again, paper 1, this is the trench, calculate the volume of the foundation. So what they've done here, they've done length times breadth times height of the foundation, and it works out to 3,6 meters cubed. Calculate what he will need to make sufficient concrete for his foundation. So let's have a look. If you go and you look in your book on page 21, we are looking at low strength concrete, which is asked in the example. You will see that 1 bag of cement, to mix, you need 1 bag of cement to 1 3/4 wheelbarrows of sand, 1 3/4 wheelbarrows of stone. Look at the bottom line. It says to make 1 cubic meter of concrete, you will need 5,8 bags of cement and 0,65 cubic meters of sand and 0,65 cubic meters of stone. Right, how are we going to work this out? You will let's delete the ink. Right, so from that ratio, we can see that we actually have 1 meter cubed of concrete. And to make that 1 cubic meter of concrete, we needed 5,8 bags of cement. That was given to us equals, I now have to have meters cubed to cement, to bags of cement. Right, they told us that in total we have 3,6 cubic meters. So in this place here, I'm going to write 3,6 cubic meters. And how many bags of cement do I need? Well, I fill in an X. Next step, ratio format. 1 over 5,8 equals 3,6 over X. Cross multiply. 1 multiplied by X is X equals 3,6 multiplied by 5,8 will give you 20,88. Go and check what you were asked to find, X. So X equal the bags of cement. So we have 20,88 bags of cement. But remember, we can't get a fraction of a bag. So for this concrete, he's going to have to use 21 bags of cement. Right, first thing you had to do was determine which type of concrete was needed. Was it the low strength or the high strength? Determine the amount of concrete needed. Well, that calculation was done for you and you were given 36,3 cubic meters. Calculate the amount of cement that was needed. Well, 3,6 meters squared, you multiplied by 5,8 and you got 21 bags of cement. Calculate the quantities of the other ingredients or the other mixture. Are we going to see what happens in this case? You are given, okay, let's just go back to that. We need a new page. So we were given that there was 1 bag of cement to 1 3/4 bags of sand to 1 3/4 wheelbarrows of stone. You knew in the previous calculation, we calculated that for that foundation of 36 square meters, you needed 21 bags of cement. You can also see here that these two are exactly the same. So what I'm going to do, I'm going to use the cement and the sand to work out how much sand I need, and then the sand and the stone will be the same amount. So we had 21 bags, so I'm going to have 21 bags of cement to X number of wheelbarrows of sand. Again, fraction form. Don't let this intimidate you. So we are not looking at that. So we're going to say 1 over 1 3/4. We're just writing it in fraction form, equals 21 over x. So again, don't worry about that because your calculator can deal with it. 1 multiplied by x is x, equals, to get this, I'm simply going to say 1 3/4 multiplied by 21. Go to your calculator. Right, now you have to remember that you can't just press the 1 and then the fraction button. You actually have to get the mixed number button, which is shift fraction button. I now have 1 3/4. Let's just go down 1 3/4. And I'm going to multiply by 21. No, wrong place. I have to multiply by 21 equals 36,75. So x equals 36,75 or 36 3/4 wheelbarrows of sand. So then I would need 21 cement plus 36,75 sand plus 36,75 stone. And that would give me 36, I think, yes, 3,6 cubic meters of concrete. Let's have a look here. We are measuring smaller quantities using a container, for example, a bucket or a spade, but you need to understand that if I'm using a bucket, I use a bucket to measure all 3 ingredients. So let's have a look and see what that, so we have, and in this case we are going to look at the medium strength concrete. So all I'm doing is I'm looking at this bottom part of the table. So we always start off with what we're given. We are given 1 cement to 2.5 sand to 2.5 stone. Okay, you have to find right, so he used 10 buckets of cement. These two once again are the same, so I'm going to work with this rate because whatever the answer to this will be the same as the stone. So I'm going to have 1 to 2.5. That is what was given to me in the table. Equals, well, the example said you had 10 buckets to X buckets. We are using buckets for all of them. Next thing we do is we write it in fraction form. So 1 over 2.5 equals 10 over X. Cross multiply again. 1 multiplied by X is X equals, again you have to go shift fraction button, and we've got 2.5, and we're going to multiply by 10, and that will give you 25. So we need 25. So if I have 10 buckets of cement, I'm going to have 25 buckets of sand, and I'm going to have 25 buckets of stone. What makes a concrete mixture strong as opposed to weak? Well, the more cement you have, the stronger your mixture. Let's look at example 3. Okay, that's the one we've just done, where he measures out 10 buckets of cement to make a small quantity of medium strength concrete. He needed 25 buckets of sand and 25 buckets of stone. What is the total quantity? The total quantity is going to be 60. Now, how did I get the 60? Well, he needed 10 cement. He needed 25 sand. We're going to add them together, and 25 stone. 25 plus 25 plus 10 will give you 60 buckets in total. What is the total quantity of the concrete? Well, it's 60 buckets. That's all for this lesson. Please will you go and do chapter 1, exercise 1, and that is found on page 23. Okay, not page 19, page 23.